What's up, you guys? This is Geometry, Module 3, Topic 1, Lesson 1, specifically page 450, last question or section on the Activity 1 out of our lessons. Now, a dilation produces similar figures, and I encourage you to have your highlighter handy. Similar figures is a vocabulary word. There it is again. Dilation is a vocabulary word, and we want to make sure we're identifying those vocabulary words whenever they show up. You are able to talk about them as their corresponding angles are congruent and the lengths are proportional. So our final vocabulary word is the idea of proportion, or the fractional relationship of the sides is the same. Use a metric ruler, so centimeters and millimeters, and what you know about dilations to demonstrate that figure E is similar to figure X. One thing we could do to demonstrate similarity is to trace shape E, and I'm going to kind of like just trace it by filling in the gaps here. And then as you slide it around, the angles that are created, you can see the angles in the corners nestling perfectly into the angles of the image or the larger shape. However, we don't always, want to use that resource as our way to justify. We want some other mathematical, numerical explanations. Here's one. Take your protractor, which has centimeter measurements on the edge, and let's go ahead and measure the distance from T to this part of the star on star E. I'm going to use centimeters, but I'm also acknowledging that when you measure like this, what we're first of all measuring is in millimeters, and then we're going to divide by 10. So I have 10, 20, 25, 26, 27. I have 28 millimeters on my protractor, and I'm going to write that as 2.8 centimeters here. Then if I go from T, I'll use a different color now, so have a different color pen if you will. I'm going to go from T, 0, out to this marker on our shape. And as I look at it, it looks like it's 10, 20, 30, 40, 50, 55, 56, or 5.6 centimeters. I'm going to kind of like add some color information to the poster so I understand that that's what I'm talking about. 2.8 is just this distance. What is that ratio? We can definitely put 5.6 into a ratio with 2.8, sir. And when we do that ratio, little subtraction, division's the key thing. We do that ratio, we wind up with 2. In essence, star X is probably bigger than star E by a scale factor of 2. Scale factor. Remember, the formula for scale factor is the image calculation divided by the pre-image measurement calculation. We want to see if that's consistently true, so I'm going to pick another pair of matching points, and I drew my arrow that went from T through star E through star X, and then using the centimeter, millimeter measurements on the ruler, I'm going to line up 0 on point T, and I'm going to go over here. I'm going to count that this is 10, 20, maybe 28. Oh, it's all the same thing. 28 as well, 2.8 centimeters. And then I'm just going to automatically project 5.6 centimeters to go out to that part of point X. Use a metric ruler and what you know about dilations to demonstrate that figure E is similar to figure X. Figure E is half the size of figure X. It has a scale factor of 2. Now, what do you know about the angles in figures E and X? All corresponding angles from E to X are congruent. And let's see here. I guess question 8 wraps up itself. That is it for question 8. The last question that we have to face is question 9. So, and I mentioned this as well in a previous video. Go back and watch page 4. Come on now, turn over the page. Page 449. It was this question right here. For those scale factors, the pre-image shrinks or the pre-image stretches. The key difference in that conversation, which is coming back right now in question 9, the scale factor that produces congruent figures is 1. In other words, 100%. If the image does not change in size, then we're just multiplying its ratios or its proportions by a factor of 1 or 100. That is it for page 450. Thank you so much for watching. I appreciate your attention and your clicking through. Please go on and look at page 451. That is the second activity. Have some of your stuff ready to go, and thank you for watching this episode.